I'm here to speak about grabs today, and how this grab conquers the cloud-native landscape. So we'll speak about the programming language Rust. I'm Sascha. I'm maintaining multiple CNCF projects for now, and some of them are also a bit rusty, you know. So let's look at all those projects we have right now in the CNCF which utilize Rust for their problem solution aspects. So interestingly, we have projects which are part of the landscape since a longer period of time, like CRI-O, but we also have like WebAssembly related projects like Wasm Edge, Wasm Cloud, but also Kubewarden, which is a policy engine written completely in Rust. And if you look closer into that picture, then you will see that there are also some projects like CRI-O and Containerd, which also utilize Rust, at least partially, for their projects. But you all know that they are mainly written in Golang. Right now, which is pretty interesting, we have like 250 million lines of code Rust and more than 370 repositories in the CNCF. So that makes it number 6 topmost programming languages in the whole cloud-native ecosystem. Now, how can we do something actually in Rust? So just rewriting something in Rust is probably not the right solution. Well, at some point it is, but you still have to, if you rewrite something, you will find out that you have to restructure it to be more modular and extendable for the future use cases. So we made the same experience in CRI-O. We had a dedicated tool, would like to rewrite it in Rust. We rewrote it in Rust, and then we just had to change the architecture while rewriting. And that was a bit problematic because you also have to change the testing. And if you change the tests, then the output might be different than before. But good interfaces will help us to cross those language borders. The command line interface is probably the most natural one when we speak about Linux. And you can also utilize RPC systems like gRPC or Captain Proto. gRPC had the issue in the past that it was not as performant as the Golang implementation, but this is somehow resolved. There are still some partially some small issues open, for example, when it comes to handling Unix domain sockets, but that's something you just have to be aware of. And on the other side, you have the WebAssembly runtimes. Like WebAssembly runtimes are more or less like awesome to handle Rust code. But for using like different libraries in your projects, there are huge amount of maturity differences if you look like how they are used, for example, in Golang considered to Rust. And also those two chains can move fast. So we had the issue that we would like to implement features in Rust which require a higher Rust 2 chain or a newer Rust 2 chain. And the issue was that just the major distributions are not fast enough for us. So we had to make the application backwards compatible to also work on older Rust versions. So how we could now fill the gaps. I think one of the best examples we have right now is youki. The first thing we had to do for youki was to find a way to actually do the OCI spec in Rust. The OCI spec is just written in Golang, but it's like a definition for how containers and runtimes should behave. And the cool thing about this is that we just spoke to existing maintainers for the OCI spec, and they said, hey, you can take over the crate, but you have to maintain it. And funny enough, we created this OCI spec RS project, which now has more than like 700 users since 2021. So we maintain it, and it's actually being used. That's a win-win. And youki is an OCI-compatible runtime comparable to run C or crun. It is way faster than run C. It is written completely in Rust, and it's now CNCF and the CNCF sandbox since 2024. So if you would like to understand how it should be made and what is the great way to understand how container runtimes work, then I can just recommend you to check out youki. But to wrap this up, I would like just to say that be careful and prepared when considering Rust for your application. Isolated functionality is always a good way to start with and to challenge like Golang implementations to find out if the problem you're solving is actually faster or does it make more sense when using a different programming language than Golang. And like the integration of like hot topics, you know, it's all AI ML nowadays, should be considered to do completely in Rust, because Rust is like memory safe, it looks for performance constraints, and it also targets like environments for various architectures. So then I'm running now out of time, but I'm happy to chat with you with Rust after that. And I wish to thank you all. Thanks.